you.
Everyone, let's start our discussion now. Ashwani, Vivek, Rupert, Rupa, can you hear me? Okay, now we are trying to focus on this section. Any question from previous session, Ashwani? Any question, Rupa, from previous session? Everyone?
Nope.
Okay, now let's focus on this section now. Into this section, wait. Into this section, we can focus on today high availability topic. Let's talk about this topic first. High availability, or you can say failover concept in Palo Alto Firewall device. High availability or failover. Any idea about high availability? Can anyone help me? Any idea about high availability concept in Palo Alto? You can say high availability. In FortiGate, you can say high availability. In Checkpoint, you can say clustering concept. Clustering concept. In ASA, you can say failover topic. Failover concept. In Cisco SA or in Cisco FTD scenario, you can say it's a failover concept. Failover. But in Palo Alto, in FortiGate, we can say high availability. Let's talk about scenario. What is the scenario to use high availability concept? So I have one firewall device. Okay, I have a design. I have one firewall device, and this firewall is connected with LAN side portion. This is your LAN side network. In LAN side, we have multiple computers. This side we are using as a ISP side network, ISP side portion. Into this design, everything is working fine. Okay, we have proper IP address configuration on interfaces. For example, this is LAN interface. IP address we are using 192.168.10.1, 10.1/24. This is public facing interface 0/1. For example, we are using 99.99.99.100. Okay, so into this design, everything is working fine. Okay, we have proper IP address configuration, routing configuration, policy configuration. You can say traffic is traveling. You can say traffic is traveling through the firewall device. Traffic is traveling through the firewall device. But into this design, we have single firewall box. We have single firewall box in case if this box goes down. If this box goes down, you will lost your connectivity. Your LAN user, they cannot go on internet side. They cannot access public resources. Okay, so we can go with backup plan or we can go with high availability concept. We can go with backup plan or we can go with high availability concept. We can add one more firewall device into this design. We can add one more firewall box into this design. This is firewall box 2. This is firewall box 1. And if I'm adding one more firewall device, let's change this design. Okay, so we have a switch. For example, this is switch number 2. This is switch number 1. So this portion is your ISP side network, and this side is your LAN side portion. So second firewall device, firewall box 2, I'm using for failover. I'm using for high availability. I'm using as a backup firewall device. In Palo Alto, in Cisco ASA, in Cisco FTD, you can configure failover, you can configure high availability only in between two firewall device. Only in between two firewall device. Okay. In Palo Alto, in ASA, in FTD. But if you go with the FortiGate firewall device, if you go with checkpoint firewall device, in a single high availability cluster, you can add maximum 8 firewall box. 8 firewall device in FortiGate and in checkpoint. But in Palo Alto, ASA and Cisco FTD. In Palo Alto scenario, we can configure high availability only in between two firewall device. Okay, and this is mode. Active passive is what? Active passive is high availability mode. In active passive, we can utilize only one firewall box in our high availability configuration. We can utilize only one firewall box. If you are working with active passive scenario, one firewall box is actively manage your traffic. For example, firewall box 1 is the active firewall box. Firewall box 2 is a passive firewall device, or you can say standby firewall device. In between firewall box 1 and firewall box 2, we have a link is called high availability link. We have a link is what? High availability link. It's called HA1. HA1, you can say control link. We have HA2, you can say data link. If you go with FortiGate, if you go with Checkpoint, if you go with Cisco ASA FTD, you need single failover link. You need single high availability link. But in Palo Alto, we need two separate link. HA1, HA1 control link, HA2 data link. So in between firewall box 1, firewall box 2, we have high availability link. Now, in case if I'm working with active passive scenario, one firewall box is actively managing your traffic, while other is in synchronization status. Other firewall box status is what? Standby firewall device, passive firewall box. So traffic is traveling. Traffic is traveling via firewall box 1. Traffic is traveling via active firewall box. Through this failover link, through this HA1 link, firewall box 1 is sending hello message to firewall box 2. Firewall box 1 is sending what? Hello packet. Keep alive message, you can say. Hello packet, you can say. HS status information, you can say. So firewall box 1 is sending hello packet. He's saying, hello, I'm active. Hello, I'm active. And firewall box 2 status is what? Passive. In case if this box goes down, if this box goes down and firewall box 2 is not getting any hello packet through this failover link because box 1 is not available. And firewall box 2 is not getting any hello packet from firewall box 1. So firewall box 2 can get an idea. Firewall box 1 is not available. Let's change mode and now I am active firewall box. Now I'm active firewall box. And traffic is automatically traveling via firewall box 2. Automatically. Firewall box 2 is a copy of firewall box 1, everyone. It's a copy of firewall box 1. Okay, you are configuring interfaces, routing configuration, policy configuration. All the configuration will replicate through this HA1 link. All the configuration will replicate through this HA1 link. If you are configuring anything in firewall box 1, firewall box 2 is a copy of firewall box 1. We have same interface. For example, fast Ethernet 0/0, IP address 192.168.10.1. This is public facing interface 99.99.99.100. We have same IP. But we cannot utilize firewall box 2. Why? Because firewall box 2 status is what? Passive firewall box. So firewall box 2 is a copy of firewall box 1. In case if box 1 goes down, in case if active box goes down, then passive box will become active. Passive box will become active. And automatically traffic is traveling via firewall box 2. Clear my point? Ashwani, Dhrupa, Vivek. Yep. Clear this point, everyone? Let's talk about some troubleshooting scenario in failover. Let's talk about some troubleshooting scenario. For example, this firewall box 1. For example, firewall box 1 is up. Firewall box 1 is up. I'm talking about troubleshooting scenario. We can discuss two troubleshooting scenario here. Let's talk about the first one. If box 1 is up, LAN interface is up. But in case if this WAN interface goes down, maybe some issue. Box 1 is up. LAN interface is up. But WAN interface goes down. Then this box is up. So this box's status is what? Passive. So all the traffic will go and hit on active box. But this firewall box 1 will not process this traffic because this WAN interface goes down, it's not working. So firewall will not process this traffic. But this box is what? Active. So all the traffic will go and hit on active box. So into this scenario, what we can do? Into this scenario, we can go with link monitoring feature. We can use link monitoring concept. We can monitor our interfaces in high availability configuration. In high availability configuration, we can monitor our interfaces. We can monitor LAN interface. We can monitor WAN interface. So what I'm doing, I'm trying to monitor. I'm trying to monitor this LAN interface, this WAN interface. Yes, when you are configuring high availability, link monitoring is a feature of high availability. In high availability configuration, you can decide your link monitoring option. You can decide. You can monitor your LAN interface. You can monitor your WAN interface in high availability. In case, if this WAN facing interface goes down, we are using link monitoring option for this interface. If this interface goes down, this box will automatically become passive and this one will become active automatically. So this is first troubleshooting method. We can go with the link monitoring option. I hope this point is clear, everyone. I hope this point is clear. Everyone can hear me. Ashwani, Dhruva, Vivek. Now we have one more troubleshooting concept here. One more troubleshooting concept. Okay. In case if this box is up, this WAN interface is up, this LAN interface is up, this WAN interface is up. Okay, but this high availability link goes down. Box is up. Box is up, LAN interface is up, WAN interface is up, but this high availability link goes down. For example, maybe you have a switch, maybe you have a layer 2 switch here, layer 2 switch for connectivity, maybe switch restart, maybe some misconfiguration in switch. My point is what? If this high availability link goes down, then box is up, but this high availability link goes down. If this high availability link goes down, then firewall box 2 will not get any hello packet from firewall box 1. He's not receiving any hello packet from firewall box 1. If firewall box 2 is not receiving any hello packet from firewall box 1, so he can get an idea firewall box 1 is not available. It's not available because I'm not getting any hello packet. So it means firewall box 1 is not available. Let's change mode. And now I'm active firewall device. But this firewall box is not down. And if you guys remember, I told you, I just said firewall box 2 is a copy of firewall box 1. So we have same interface IP here. Same interface IP. If this box will become active, then we have same IP address configuration on interface. You can face some issue, IP configuration issue. So into this scenario, what we can do, we can go with backup plan. We can add HA1, HA2 backup link. We can go with backup interface option. We can add HA1 backup link. We can add HA2 backup link. So you can add only one backup link for HA1, one backup link for HA2. So if HA1 link goes down, HA1 backup link will take the responsibility. In Palo Alto, we can add only one backup link. Only one backup link. If you go with the FortiGate, you can add multiple backup links. If you go with checkpoint firewall device, you can add multiple backup links. In Cisco ASA, there is no option for backup link. In Cisco FTD, yes, you can go with the backup link. In Palo Alto, yes, you can go with the backup link, but you can add only one backup link. In FortiGate, in checkpoint, you can add multiple backup links. If one HA interface will goes down, the next one will take the responsibility. So this is second troubleshooting concept. If HA1 link goes down, then backup link will take the responsibility. Now, what is the requirement? What is the requirement to configure high availability? For example, I want to configure high availability in my network. What is the requirement? What is the requirement to configure high availability? So the requirement is, first, you need same model. You need to have same hardware model. For example, if this one is PA 500, this one is PA 2000, you cannot establish high availability. You need same hardware model. Second requirement, you need same PAN-OS version. same PAN OS version. For example, here you are using 9.0.0. Here you are using 10.0.0. You cannot establish high availability. You need same set of licenses. You need same set of licenses. Licenses. Same type of interfaces. Same type of interfaces. So this is the requirement for high availability. Same hardware model, same canvas version, same set of licenses on both the devices, same type of interfaces. Let's discuss some other points with slides. Okay, right. So in case if you have high-end model, for example, you have BA 5000, 7000 model. So in high-end model, you can get dedicated HA port. Okay, you have dedicated HA port, high availability link. But in entry-level firewall device, like you have PA 200, 500, 1000, in entry-level firewall device, you have only data interfaces. You have only data interfaces. See this point. If you have high-end model, if you have high-end model, for example, PA 3000, 4000, 5000, 7000 model, then you will get dedicated HA port. See, HA1, HA2 link. But in case if you are working with entry-level firewall device like PA 200, 500, 2000, so you can use your data interface. You can use your data interface as a high availability link. So we can go with active passive scenario. In active passive, one firewall box is actively manage your traffic, and the next firewall device status is what? Standby. What is the requirement? What is the requirement? You need same model. This is the requirement for high availability. You need to have same model, same canvas version, same type of interfaces, same set of licenses. But you can see this line, this line. HA interface must be configured with static IP. HA interface. Okay, if you remember, we need high availability link. We need high availability link in between firewall device. For example, this is firewall box 1, this is firewall box 2. So in Palo Alto, we need two separate link. HA1, it's called control link. HA1, it's called control link. We have HA2, it's called data link. Data link. And it's a L3 interface, everyone. HA1 and HA2, it's a L3 interface. So you need to configure IP address statically, manually. You need to configure IP address on these interfaces statically or manually. If you are working with FortiGate firewall device, no need to configure any IP address on HA interface. In FortiGate, it will automatically get IP address from APIPA. Remember APIPA range 169.254, it's APIPA range. But in Palo Alto, in ASA, in FTD, in Checkpoint, you need to configure IP address on HA interface manually statically. No, what is HA1 interface? What is HA1? Control link. What is control link? What is the use of this control link interface? So this control link, it is used to exchange hello packet information, heartbeat information, and HA status information. So through this HA1 link, firewall box 1 is sending hello packet information. Through this HA1 link, sending hello packet information, keep alive message information, heartbeat information to firewall box 2. And whenever you are configuring anything in firewall box 1, all the configuration will replicate through this HA1 link. All the configuration will replicate through this HA1 link with firewall box 2. So firewall box 2 is a copy of firewall box 1. Wherever you are configuring anything on active box, all the configuration will replicate through this HA1 link. Okay, you are configuring routing configuration, policy configuration, interface configuration. Now, this HA1 port is using TCP port number 28769, TCP 28260 for clear text communication. clear text communication. So if anyone will capture this packet, on this interface, can verify what configuration, what information is traveling through this HA1 link, can verify because it's a clear text communication. If you are looking for encrypted communication, then you can select a checkbox. I will show you practically, okay? No problem. But you can select a checkbox for encrypted communication. For encrypted communication, it's using port number 28 for encrypted communication. What is the use of this data link? What is the use of this data link? Data link, HA2 data link. So data link, it is used to synchronize sessions, forwarding table, IP security association information, ARP table information. So these information will exchange through this HA2 interface, HA2 data link interface. For example, this box is active and this box is status what passive. All the traffic is traveling via this active box. And when traffic is traveling through the firewall box, Palo Alto is a stateful firewall device. When traffic is traveling through the firewall box, then firewall will maintain the state of connection in session table. In connection table, in session table. And this session table information, firewall box 1 will exchange with firewall box 2 through this HA2 interface. Through this HA2 interface, through this data interface. Session information, forwarding table information, IP security association information, ARP table information. These information will travel through this data link, through this HA2 interface. Ashwini clear? Rupa, Vivek? Everyone clear? Now let's talk about link monitoring. I just said we can monitor our LAN interface, right? We can monitor our LAN interface, WAN interface into this design. We can monitor our WAN interface, LAN interface. You can go with path monitoring. You can monitor your path. For example, from firewall box 1, okay, this box is active. So from this firewall box 1, I can send a ping request, for particular destination. On internet side, I can send a ping request for particular destination. In case if reply packet is not coming, so this firewall box will automatically become passive and this one will become active. So we can monitor our link, our connected interfaces, and we can monitor path also. I will show you practically both the option, how to monitor our interfaces, how to go with path monitoring option. Practically, we can verify. Okay, we need priority value. When two Palo Alto firewall box are deployed in active passive cluster. It is mandatory to configure device priority and high priority value for passive and low priority value for active. So if I want to use firewall box 1 as a active firewall box, I will go with lower priority value. So high priority value for passive and low priority value for active firewall box. Okay, let's discuss rest option in lab. So we have a design. Wait. Let's go with the practical example. We have a design, everyone, okay? For active passive implementation, we have this design. Let me explain this topology. Okay, we have two firewall box. We have firewall box 1, firewall box 1, firewall box 2. We are trying to implement active passive scenario. We have two firewall device. Both the firewall device, see, on both firewall device, we have management port. So management port, I'm using with this management network. This portion is what? Your management network. So both firewall management port is connected with this management switch and we have management PC. Now Ethernet 1/1, Ethernet 1/1. It's a LAN facing interface. So both firewall Ethernet 1/1 interface I'm using for LAN side portion. So we have LAN side network and this side Ethernet 1/2, Ethernet 1/2. This portion is what? WAN side interface. WAN side network. On WAN side, I'm using 10.1.13 network. LAN side, we are using 200 network. In between firewall box 1 and firewall box 2, we have failover link HA1 and HA2 failover link. Ethernet 1/4, Ethernet 1/4 I'm using as a HA1. Ethernet 1/3 I'm using as a HA2 interface. And both are L3 interfaces. So we need to configure IP address on this high availability link. Let's configure IP address HA1. HA1 is 10.20.20.0 network, and HA2 10.40.40 network /24. Clear this design, everyone? Ashwani, Dhrupa, Vivek, can we start our configuration, everyone? Okay, it's a new design. Okay, so we need to configure IP address on management port. Let's configure IP address on both firewall management interface. It. As per our design, you can see 199 network, 199.199.199.0 network we are using for management. So now configure set device config system type static. Set device config system IP address 199.199.199.1 net mask 255.255.255 project. Commit. We can commit our configuration. Let's go with the firewall box 2. Now configure set device config system type static. Set device config system IP address 199.199.199.5 net mask 255.255.255.0. Let's commit our configuration. Let's go with the management PC. So I'm trying to access both of our device with this management PC. Okay, this is management PC and I'm using same subnet of IP. Let's verify 199.199.199.14. We can verify our connectivity first. 199, 199, 199. This is firewall box 1. 199.199.199.5. This is firewall box 2. Let's try to access both of our device with graphical page. HTTPS 199.199.199.1. This is firewall box 1. Please wait. Okay, it's working very slow. Okay, so this one is firewall box one. You can verify with the IP address 199.199.199.1. This is firewall box one, everyone. Firewall box one. We can try to access firewall box two. IP address we are using 199.199.199.5. Okay, now everyone can hear me. Ashwini, Rupa, Vivek. Everyone can hear me. Okay, let's continue our practical implementation. So this is firewall box for everyone. And both the devices, they are not participating in any failover configuration. Okay, if you click on here on dashboard, we can check our high availability status. So you can add your high availability. So both the firewall devices, they are not participating in any failover. See, HA not enabled. HA not enabled. Let's go to firewall box 2. Firewall box 2, and we can add HA status information on dashboard. So high availability, both of our device, they are not participating in any failover configuration, in any high availability configuration. Let's try to configure high availability first. After that, we can go for basic configuration like LAN interface, WAN interface, routing configuration, policy configuration. We can configure later. First, we'll establish high availability. So into this design, we are using entry-level firewall device. We don't have dedicated high availability link. So we are using into this design data interfaces. Data interfaces, Ethernet 1/4 and 1/3. These two interfaces we are using as a high availability link. So you can go to network tab. You can go to network tab and Ethernet 1/3. This interface, 1/3 interface, I'm using as a HA interface. So you can select your interface type. You can select your interface type is what? HA. HA. You can click on, okay. You cannot configure anything here. Okay? You can just select your interface type. 1/3 we are using as a HA1, 1/4. 1/4 is it's a HA interface. Now you can commit your configuration. So both the interfaces we are using as a high availability link. High availability link. Let's go to Palo Alto Firewall box 2. Network tab. Network tab. We can go to interface tab. As per our design, 1/3 and 1/4. Both interfaces we are using as a high availability link. So interface type, I'm using HA. HA, you can click on OK. Internet 1/4. 1/4 interface type. HA, you can click on OK. We can commit our configuration. We can commit our configuration. Commit. This will take time. Can we take a break for 8 minutes, everyone? 6:37 on my side. Can we continue at 6:45, everyone?
Yep,
Okay,
sure.
this will take time. Okay, let's take a break. Please turn off your mic. Hi everyone, can you hear me? Ashwani, Dhrupa, Vivek.
Yep, we can.
Okay, let's continue our session now. Okay, so into this design, Ethernet 1/4 and 1/3. These two interfaces we are using as a high availability link. Okay, let's start our configuration with firewall box 1. This is firewall box 1. We can verify management IP. This is firewall box 1. Let's go to device tab. Device tab, we can go with high availability tab. In device, we can go with high availability tab. In high availability tab, we can go with general setting. So by default, HA not enable. HA not enable. You can go with edit button. You can enable HA. You can enable HA. You can select a group ID number. You can select a group ID number. You can select a number in between 1 to 63. For example, if I'm using group ID number 1, so same number we will configure on firewall box 2. So I'm using group ID number 1. Into this design, we are working with mode active passive. We are using mode active passive. Now it's looking for peer HA1 IP address. Peer HA1 IP address. Okay, so we are here. We are here in firewall box 1. This is what firewall box 1. As per our design, Ethernet 1/1 interface, Ethernet 1/1 interface, sorry, Ethernet 1/4 interface, we are using as a high availability link. We are using as a HA1 interface. And Ethernet 1/3, we are using as a HA2 interface. So into this configuration tab, it's looking for peer HA1 IP address. Peer HA1s, okay. So into this design, this Ethernet 1/4, it's a 1/4 interface. It's a HA1 interface. And this is peer firewall box. Firewall box 2, it's a peer firewall device. So it's asking for peer HA1. So this one is this one is a peer HA1 interface. And here we are using 10.20.20.2. Here we have .1. Here we have 10.40.40.1. Here we have 40.40.40.2. So it's looking for peer HA1. So peer firewall device is firewall box 2. And peer HA1 IP address is 10.20.20.2. Let's create an entry here. So 10.20.20.2. Okay, we don't have any backup link. So if you have backup link, you can create your entry, but we don't have any backup link here. You can just click on OK. Now here we have hold down timer. Default hold down timer is what? 1 minute. What is hold down timer? So in case if this box goes down, firewall box 1 goes down, then firewall box 2 will wait for 1 minute. Firewall box 2 will wait for 60 seconds. In 60 seconds, if firewall box 1 is available again, it's an active device. But in after 1 minute, after 60 seconds, if firewall box 1 is not available, then firewall box 2 will become active. So hold down timer is what? 1 minute. After 1 minute, firewall box 2 will become active. Now you can change your timer if you want. You can change this timer. This is default one. Now we can go with priority setting. As per our theoretical discussion, low priority value for master, for active, and high priority value for sleep, for backup. So you can set your priority value. So for example, here I'm using priority value 110. You can enable preemption technique here. What is preemption technique? It's a common topic. In networking, it's a common topic. If you remember HSRP, VRRP, OSPF, preemption is a common concept. What is preemption? By default, preemption is not enabled. By default. What is preemption? Preemption is not enabled. So if preemption is not enabled, then what will happen? In case if this box goes down, firewall box 1 goes down, and firewall box 2 is an active firewall box now. After some time, if firewall box 1 will come up again, if firewall box 1 will come up again, this firewall box 1 will become standby. It not become active again. Okay, firewall box 1 has a higher priority value, but it will not become active again. No, because preemption technique is disabled. If you enable preemption technique, then if active box goes down, and after some time, if it will come up again, it will become active again. So if you want firewall box 1 goes down and when it will come up, you want to use firewall box 1 as an active box, you can enable preemption. You can enable preemption technique. You can click on OK. So here we are using priority value 110. Now we can decide. Now we can decide HA1 and HA2 interface. You can go with this tab option, HA communication. You can go with this tab option, what? HA communication, this tab. HA communication. You can click on here. Now we can decide HA1 and HA2 interface. Into this design, Ethernet 1/4, you can see Ethernet 1/4 we are using as a HA1 interface. So here we have control link, and we have data link. If you have backup link option, you can select these options for backup. HA1 backup link and HA2 backup link. Now let's try to configure HA1. You can click on edit as per our design. Ethernet 1/4. So we can select our interface. Ethernet 1/4. 1/4 we are using as a high availability link. HA1 interface. IP address as per our design 10.20.20.1. Now you can set a mask. You can see it's looking for gateway IP. It's looking for gateway IP. Why gateway IP here? Why gateway IP here? Because we have the same subnet. Why gateway IP here? In case if you have a router this side, in case if you have a router device, and if you want to travel through the router, then you need to set gateway IP. In case if you have router, we don't have any router, we have same subnet of IP. Okay, so gateway is not required. I told you default communication is a clear text communication, but if you want to encrypt this communication, you can just select this checkbox, HA communication. Now you can click on OK. This is HA1 interface, HA2 as per our design, Ethernet 1/3. Ethernet 1/3 we are using as a high availability link to data link. You can see session synchronization option is enabled by default. It's enabled by default. What is session synchronization? If traffic is traveling via firewall box 1 will maintain the state of connection in session table. This session table firewall box 1 will exchange with firewall box 2. Session table information will exchange with firewall box 2. Because by default session synchronization option is enabled. What is the benefit? What is the benefit if firewall box 1 is exchanging session table information? What is the benefit in case if this box goes down and reply packet, for example, reply packet is coming via this side because this box is active now. Reply packet is hitting to this firewall box 2. Firewall box 2 will allow this reply packet. Why? Because firewall box 2 has session table information. If you remember, I told you when reply packet will come, firewall will verify this traffic information in session table. If information is available, traffic is available. So session synchronization option is enabled. If you want to disable, no problem. But by default, it's enabled. By default, it's enabled. As per our design, port number 1/3 we are using as a HA2 interface. So interface is 1/3. IP address we are using 10.40.40.1. Mask 255.255.255.0. You can click on OK. Done. We can commit our configuration. We can verify on dashboard. Wait. This will take time. Okay, let's try to prepare our LAN machine and WAN machine. Wait. Once you commit this configuration, you can verify HS status again on dashboard. Let's go to dashboard, HA status. Now you can see we are getting some information here in high availability. It's taking time. Okay, wait. It's taking time. It's taking time. Let's prepare our outside router. This is outside router. For testing, I'm using this outside router IP address as per our design. For outside network, we are using 10.1.23 network, this subnet of IP. Let's configure IP address. Host name, it's a gateway device. Now interface Ethernet 0/0. IP address 10.1.23.10 mask. No shutdown. We can set a gateway entry. So for any unknown destination, 10.1.23.1 is the next hop IP. So this IP we will configure on firewall WAN facing interface. Okay, so this router is ready. Let's go to check this LAN machine. LAN machine, I think we have proper IP address configuration on this LAN machine. Wait. IP address 200.200.224. Yes, we have proper IP address configuration and gateway entry. Okay, let's go to Palo Alto Firewall device. Okay, so we can refresh this page because default refresh timer is 5 minutes. You can refresh your page manually. Now you can see this firewall box 1. Local firewall box is active. Peer is unknown right now. We can configure, okay? We can configure on firewall box 2, high availability, but right now it's unknown. Everything is unknown. Let's go to firewall box 2. Firewall box 2, device tab, high availability. We can enable HA. Enable HA group ID number. We are using 1. And what is peer? What is peer IP address? So peer IP address you can see as per design 10.20. 10.20.20. Click on OK. Peer HA1 IP address. Now you can set your priority value. I want to use this box as a passive firewall device, so we can use higher priority value here. So I'm using 125. 125. We can enable preemption here. You can click on OK. Let's go to HA communication as per our design 1/4 interface. 1/4 interface we are using as a high availability link 1, HA1. So 1/4 IP address 10.20.20.2 mask. Click on OK. Let's go to data link. Data link interface 1/3. It's a HA2 interface. IP address 10.40.40.2 mask 255.255.255.0. Click on OK. We can commit our configuration. Please wait, okay? This will take time. Any problem in configuration, everyone? Ashwani, Rupa, Vivek. Now we can verify. Now we can verify dashboard. Let's go to firewall box 2. We can verify dashboard information on both the firewall device. We can refresh this page. Now you can see we are getting some message here. This is firewall box 1. You can verify with management IP. This is firewall box 1, 199.199.199.1. This is firewall box 1. So this firewall box 1 is an active firewall box right now. Firewall box 2, this is management IP of firewall box 2. Firewall box 2 status is what? Passive firewall device. Passive firewall device. Running configuration is not synchronized. It's taking time. Okay, no problem. But you can see other information match, 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 match. If you verify on firewall box 2, this is management IP 199.199.199.5. This firewall box 2 status is what? Local firewall devices, passive firewall device. And this is management IP of firewall box 1, 199.199.199.1. This firewall box 1 status is what? Active. Clear this point? Ashwani, Dhrupa, Vivek, everyone. Clear this point, everyone? Clear now? Okay, now let's go for basic configuration. Okay, now I'm trying to configure LAN interface, WAN interface, policy configuration, routing configuration, and you can verify whenever you are configuring anything on active appliance, active firewall box, all the configuration will replicate through this HM1 link. Replicate on firewall box 2 through this HM1 link. We can verify. Let's go to network tab. Let's go to network tab. This is firewall box 1, where you can verify with management IP. This is firewall box 1. So now let's try to prepare our LAN interface, WAN interface. So Ethernet 1/1 as per our design. As per our design, it's a L3 interface. Virtual router, I'm using default. Let's go with the default virtual router. We can create a security zone. We can create a zone. It's a LAN zone. LAN hyphen zone. You can click on OK. Now IPv4 address. Static IP. Static IP. So we can create object LAN 200.200.200.1. 200.200.1/24. Click on OK. Now advanced management profile, MGMT. We can enable some service, ping service, for example, I'm using. So I'm trying to prepare LAN interface and WAN interface. Okay, this is LAN interface Ethernet 1/1 and 1/2 interface we are using as a WAN facing interface. Interface type L3. Virtual routers default. Security zone we can create. WAN zone. WAN zone, click on OK. Now IPv4 address, we can create object WAN 10.1.23.1. 10.1.23.1/24. Click on OK. Now advanced management profile we can create, we can attach here. MGMT, click on OK. Now let's configure default route, virtual router. This is the virtual router default. We can configure default route towards this ISP gateway. We can configure default route toward this ISP gateway. Add name default route. So for any unknown destination, this is default routing syntax. Remember in CCNA training, any network, any mask, exit interface is Ethernet 1/2 and next hop IP is 10.1.23.10. This IP address we are using on router side. We are using on gateway router. You can click on OK. Click on OK. Let's configure policy also to allow our traffic. Policy. Rule 1. Rule type Rule type, interzone communication rule. Source, if traffic source is LAN zone, source address any. Destination is WAN zone, any application, any service URL category. Action I'm using allow. Now you can click on. Let's commit our changes. So we have this configuration on firewall box 2. In firewall box 2, you can see interface configuration, LAN interface, WAN interface, default routing, policy configuration here. So we have this configuration in firewall box 1. Firewall box 1. This configuration you can verify in firewall box 2. Okay, wait. Because firewall box 2 is a copy of firewall box 1. Configuration will automatically replicate in firewall box 2 through this HA1 link. Okay, let's go to dashboard. Okay, we can refresh this page. Let's go to firewall box 2. We can refresh this page. Okay, let's check here. I think we are not receiving. Okay, we don't have IP address information right now. Okay, so let's go to firewall box 1. No problem. Let's go to firewall box 1 and we can click on synchronize to peer. Click on here, click on yes, and wait. Right now, here is the status not synchronized. Now let's see a new message. Synchronization in progress. Synchronization in progress. And if you check on firewall box 2, dashboard, it's taking time. Okay, wait. Synchronization is in progress. Wait. Once it completes, you will get a message here, synchronized. You will get a message here, synchronized. It's taking time. Now we are getting a message. This is firewall box 2. We are getting a message synchronized. You can also verify with firewall box 1. Okay, let's refresh this page manually because default refresh timer is 5 minutes. We can refresh manually. See, synchronized. If you are getting this message synchronized, so let's verify. Let's verify in firewall box 2. You can go to network tab. You can verify interface configuration. Yes, yes. See, this is firewall box 2. This is firewall box 2. Management ID. Firewall box 2. You can also verify policy configuration. Policy configuration. Yes, policy configuration is available. So as per our task, as per our design, firewall box 1 is a active firewall device, right? See, firewall box 1 is what? It's a active firewall device right now. Okay, and you can verify traffic is traveling. We can try to initiate our traffic. I'm trying to travel through the firewall device. Okay, I'm trying to ping 10.1.10.1.23.10 with -T. I'm trying to travel through the firewall device and see traffic is traveling. I'm initiating my traffic. I'm initiating my traffic from this LAN machine. Traffic is traveling via firewall box 1. Why? Because firewall box 1 into this design, firewall box 1 is a active firewall device. Firewall box 1 is a active firewall device. Now, in case if this box goes down, wait. Now, in case if this box, firewall box 1 goes down, this box right now, it's an active firewall device. And in case if this box goes down, We can power off. Box goes down, then you can see. I'm getting some packet loss here. See, request time out. It will wait for only 60 seconds. Only 60 seconds. I'm not getting reply. Packet loss. After 60 seconds, you will get a reply packet. Wait. 60 seconds. See, again, you are getting a reply packet. Traffic is traveling. Traffic is traveling, and you can see, you can verify on firewall device. If you refresh this page, this is firewall box 2. This is firewall box 2. And if you refresh this page, if you go to verify on dashboard, you can see this firewall box 2 status is what? Now active. See, active. Clear, everyone? Firewall box 1 goes down, then firewall box 2 will take the responsibility automatically. You can see traffic is traveling via firewall box 2 because firewall box 2 is what? It's a active device. Everyone clear? Clear this point? Ashwini, Dhrupa, Vivek. Now, in case if this box will come up again, this box will come up again. What do you think, everyone? It will become active again, right? Because we have least priority value and preemption is enabled. Remember, preemption is enabled. So this box will come up again. It will become active again. We can verify. Okay, this will take time. This firewall device will take time. 10 to 15 minutes. Can we take a break for 10 minutes, everyone? For verification? Can we take a break for 10 minutes? This firewall box will take a time. So for verification, we can take a break for 10 minutes. 7:21, we can continue at 7. Okay, it's a 7:11. We can continue at 7:21. Okay, please wait. Hi everyone, can you hear me? Okay, let's verify now. Let's verify now. We can log in Palo Alto Firewall box 1. Okay, wait. This is Firewall box 1. This is Firewall box 1, and you can see this firewall device is what active. This firewall device is active. You can verify graphically. Wait. So we have least priority value and preemption technique is enabled that. So firewall box 1 will become active again because we have least priority value. We are using priority value 110. You can verify here firewall box 2. Firewall box 2 is now passive again. This is firewall box 2. It's a passive again. And if you verify on firewall box 1, wait, it's taking time. You can see firewall box 1 now again active device. So I hope this high availability topic is clear. This high availability concept is clear, everyone. Ashwini, Rupert, Rupa, Vivek. We can discuss one more point in high availability. Clear this verification, everyone? Clear this verification? Clear. Okay, now. So let's go with some other task in high availability. Okay, let's go to active box again and we can go to device tab. Now I'm talking about link monitoring and path monitoring. We can monitor our LAN interface and WAN interface. So if you want to go with link monitoring option, you can go to device tab. In high availability tab, now you can go with link and path monitoring. If you want to monitor any interface, you can see the condition is what? Condition enable failover condition is what? Area. Failover condition any for interface. If interface goes down, you can click on here, edit. See, failure condition is what? Any, I don't know. Okay, my point is what if in this interface is not working? If this interface goes down, then firewall box 1 will become standby, passive, and firewall box 2 will become active. You can monitor your interface. You can add your interface. Click on add. You can add your interface. For example, I want to monitor Ethernet 1/2. This is a WAN facing interface. I want to monitor Ethernet 1/1. This is LAN facing interface. You can give a name. You can give a name link 1. Just click on OK. So you can monitor your interfaces. You can go with path monitoring. You can go with path monitoring. For example, from firewall box 1, I'm sending a ping request, ping message to outside gateway. Outside gateway. If reply packet is not coming, this box will become standby or passive automatically, and this one will become active. Let me show you. Wait. Let's go with path monitoring, this option, path monitoring. We can add virtual router path. We can add one virtual router path. Here we have a default one. Now we can click on add. We can give a destination IP group. You can type any name, no problem. Like gateway 1. What is destination IP? Destination IP is 10.1.10.1.23.10. So I'm trying to ping gateway IP. I'm trying to send ping request for this gateway IP. Click on OK. Click on OK. We can commit our changes. We can commit our changes here. You can see we are getting reply. You can see we are getting reply from LAN side. I'm getting reply and I can ping to 10.1.23.10. Let's go to this outside gateway router and what I'm doing. outside gateway router. Show IP interface brief. I'm trying to shut down this interface. I'm trying to shut down this interface because path monitoring is enabled. And firewall box one is an active firewall box right now. You can see this is firewall box one and status is what? Active. Now we can go to interface Ethernet 0/0 shutdown. Shutdown. We are sending a ping request. We are sending a ping request from firewall box one. If reply packet is not coming, firewall box one will become passive and this will become active. So we can verify here. Let's refresh this page manually. We can refresh this page. It's taking time. Okay, wait. It's taking time. This interface is shut down. Let's verify. Show IP interface brief. Yes, this interface is down. We can refresh. Wait. Now you can see everyone. Here we have a message. See, here we have a message. This is firewall box one, everyone. Non-functional path down. See, path is down now. If path is down, so you can verify now. You can verify this firewall box two. You can refresh this page. You can see this firewall box two is now again active. Firewall box one is down now. See, non-functional path down. So path is down. That's why this box will become passive and this one will become active. And this is our topic, high availability. I hope this topic is clear for you, everyone. This topic is clear for you. Ashwani, Dhrupa, Vivek.
Yes, clear.
Okay.
Jitu, one request. Once this class over, can you send these PDFs on the email?
Sure.
Thank you so much.
You're talking about this slide? You're talking about this slide?
No, I'm talking about this PDFs that all the content is covered. PDF.
Okay. Sure. I will share in group, no problem. Okay, so this is what our topic, high availability implementation. Let's continue our topic tomorrow, and tomorrow we'll focus on first user ID. Yes,
I have
Vivek?
one question. When you talk about HA mode, active, and active passive, the panel asked the question that which HA mode is more preferable and more suitable for any organization. So
Active passive is a popular option, Vivek.
active
Passive is a popular option because in active, they are sharing load. Okay. So in active, one box is a controller device. One device, see, both the devices are in active state. But one is a controller device. Controller means what? All the traffic will go and hit on controller device first. Then controller will share this load with firewall box 2. Okay.
got it.
This is the issue, okay, because traffic is not directly traveling through firewall box 2. Traffic will first hit on controller device. Controller will share this load to firewall box 2. Then firewall box 2 will process this traffic. Okay.
So will this be a cost effective as well as compared to active?
See, it's a mode, okay? It's a mode. If you want to go with the active passive, in active passive, only one firewall box is utilizing your traffic. In active, the traffic will slow because traffic is not going to hit directly on firewall box 2. Traffic will hit on controller device. Controller will share the load with firewall box 2. So you can face some slowness in traffic.
Got it.
That's why active passive is a part. Can you send the high availability slide? It is already shared, Rupa. Okay, you can check mail. Okay, I already shared all Palo Alto slides. Otherwise, I will share again, no problem.
Thank you, Sumanjit.
So this is our topic, everyone. This is our topic. Wait, it's a high availability. Tomorrow we'll focus on the user ID topic first. User ID, and if we have a time, I think we'll take time. User ID will take approx one session. One session. So let's talk about user ID first tomorrow. Bye everyone. Take care, guys.
Thank you, Sumanjit.
Please connect tomorrow same time. Bye everyone.